Welcome back, everybody. We're talking about momentum today, and we've already seen that momentum is conserved. When two things bang into each other, the same amount of momentum that was at the beginning is at the end. You can have things slow down or speed up as one thing crashes into another, but ultimately the same amount of momentum that you have at the beginning is the same amount at the end. And momentum, remember, is the product of a mass times the velocity of that mass. So here we have Granny on roller skates. So it says Granny whizzes around the rink and suddenly confronted Ambrose at rest directly in front of her path. So he's stopped and she's moving. Rather than knock him over, she picks him up and continues in motion without braking. Okay, so essentially they're going to crash. She's going to pick him up and they're going to keep moving. Now she's got some speed, he's got no speed. She's big, he's little. So what is your guess? What's going to happen? So consider both Granny and Ambrose as two parts of one system. Since no outside forces act, the momentum before the collision is exactly the same after. So she's got momentum because she has mass. She's 80 kilograms, going at 3 meters per second. So what is her momentum? So 3 times 80 is 240, and momentum is kilograms meters over seconds. So kilogram from mass times meters all over seconds. So she's got 240 kilograms meters per second. What you're going to see is that amount of momentum is going to be the same at the end after she picks up the kid. He has 40 kilograms of mass but no speed. So since he has no speed, 0 times 40 is going to be 0. He has zero momentum, and the total is going to be his momentum plus hers. So there's a total of 240 kilograms times meters over seconds. So this is what is going to be at before the crash, and then after the collision, you're going to have exactly the same amount. This is called conservation. It's conserved. The same amount of momentum at the beginning is the same amount at the end. After the collision, does Granny's speed increase or decrease? Well, what's logical? She's going 3 meters per second. She picks up a 40 kilogram kid. She's going to slow down. So this is a decrease in speed. He was going nothing. He was standing there. And so now he's moving. So she's picked up weight but still moving. She slows down. He speeds up. He speeds up because he is now moving. He wasn't moving before. So we're going to need now the total mass, because remember, it's mass times velocity, and I'm going to have a new velocity because she's slowing down. I also have a new mass. So she's 80, he is 40, so now they have a total combined mass of 120 kilograms. And then after the collision, what's the total momentum of both of those together? The same as what she had at the beginning. It's conserved. So she had 240, he had 0. At the end, they are still 240, and remember, momentum is kilograms times meters over seconds. So we're going to use the conservation momentum to find how fast that they're going together. And I didn't give you this formula yet, so I'd like you to write it down in your notebooks. We've got the momentum of Grandma. Let's make her a big M, and she had a speed. And then you're going to have Ambrose's mass, and we'll call that V1 since you know that's a different velocity. He was going 0, she was going 3. And at the end, you're going to have a combination. So you're going to have the masses are added because they're connected together. So we're going to have both of those masses together. That was the 80 plus the 40 is the 120 masses together. And then together, they're going a new speed. Okay, so we know that this is 80 kilograms times, she was going 3 meters per second. He was 40 kilograms, and he was going 0 meters per second. Together they are 120 kilograms, and we don't know what their speed is. That's what we're going to try to find out. So this becomes 0. This was whatever our total momentum, 240 kilograms meters per second equals 120 kilograms. You see kilograms are going to cancel, leaving you meters per second, which is speed. That's what we want, times V. And then when you take 120 into 240, we're going to say that she's now going 2 meters per second. So she slows down from 3 meters per second to 2. He speeds up from 0 to 2 meters per second. Okay? Hope you're learning.